Okay, we know that how to find the sum of n terms of arithmetic series is given by summation of any terms is equal to n divided by 2, open the bracket, a1 plus an, close the bracket. A1 is the first term of an arithmetic series, but also an is the last term of arithmetic series. Sn stands for the sum of any terms, but also n stands for number of terms of a given arithmetic series. So we want to prove that this formula is correct. Now, in order to prove this formula, we have to consider the sequence A1, A2, A3, up to AN. According to the definition of terms of arithmetic sequence or arithmetic progression, we find that A1 is always equals to A1. But if we want to get the second term, you have to add the first term by a common number, which is called the common difference. And we always use the letter D to represent that common number, which is called the common difference. So our terms will be A1, A1 plus D. In order to get the third term, we will take A1 plus 2D, meaning that you take that common number, which is the common difference, is added 2 times. The process continues up to the last terms. Here you can see that I have written an minus 2d, and the other one is an minus d, and the last one is an. This is because the numbers or the terms which appears before an differs from an by the common difference. Therefore, if your last number is 5 and the common difference is maybe 2, if you want to get the number before an, which is 5, you will take that last number minus the common difference. So we will take 5 minus 3, and we will remain with 2, which is the number before an, which is 5. Therefore, with that regard, we say that the numbers before an will be an minus d, and the other one will be an minus 2d. After understanding that, now we can find the sum of those terms from the first one to the last one. That the sum of any terms is equal to a1 plus d. So I am adding those terms which we found there. We considered that a1 plus d, a1 plus 2d, and so on. So here we are just adding them to get the sum of the n terms. So we will add them up to the last terms, and there we will get the first equation. We will call it equation 1. So this one is called equation 1. This one, equation 1, where we have added the terms from the first to the last one. So this is equation number 1. Again, we can formulate another equation by reversing the terms of the first equation. Here, on the second equation, we will start by writing the last terms. For example, here we have an plus an minus d plus an minus 2d. So these are the terms which were the last in equation number 1. Therefore, we will proceed by writing while reversing them like this. Plus, we continue here. There are so many terms here, so we add. Then these are the terms which started on equation number 1. Therefore, this one will be the last terms in equation number 2. After this, we have to add the two equations, the first equation and the second equation. So here, if we add, we have Sn plus Sn. We will get 2Sn, as you can see here. Then we will take A1 plus An. We get this one. If we take this one plus this d is positive and this d is negative. So when you add them, you will get 0. So A1 plus An, we will get this one. Then 2d and negative 2d, once being added, they will give us 0. But we will remain with A1 plus An, which is this one. So the process will continue. Here there are so many terms, but also here we have the terms. So when we continue with this process, all those we will remain with A1 plus An, A1 plus An, A1 plus An, because these values of common differences will be, when being added, will give us 0, 0. So we will remain with A1 plus An, A1 plus An. So these are, so they are many, because the last term is An, because the number of terms is n. Therefore, if we count these terms goes up to n. So when you count them, you will get A1 plus An n times. Therefore, we want to find the sum of these. We will take one term, which is A1 plus An, because these are the same. Then we multiply by the number of terms, which is n. That's why here you can see here that A1 plus An, A1 plus An, A1 plus An, these are the same. So we pick one and then we multiply by the number of terms. I think you remember when we were just adding 5 plus 5 plus 5. If I want to use multiplication here, I will take one term, which is 5, then I multiply by the number of 5s, and by the number of terms, which is 1, 2, 3. So I will get 15. So even here, we can take A1 plus An, then we multiply by the number of those terms. After doing this, this is the same as you write like this. So after that, we will divide both sides by 2 to get this formula. So the sum of the n terms will be equal to the number of terms divided by 2. Open the bracket, A1 plus An, close the bracket. This is our formula of finding the sum of n terms in arithmetic series. But also you can define this one, because we know that An is the nth term of arithmetic progression. So we know that An is equal to A1 plus n minus 1 bracket d. So if you take this one and you put where there is An in our formula, you will get the simplified formula, which will be a1, no, n over 2, a1 plus, this one is a1 plus n minus 1 bracket d, like this. So I have to combine this and this. So I will get 2a1 plus n minus 1 bracket d, while outside there is n over 2. So the simplified formula will be sum of n terms is equal to n over 2a1 plus n minus 1 minus 1 bracket d. This is the simplified formula of finding the sum of n terms, where n is the number of terms. And the S stands for sum. A1 is the first term of an arithmetic series. D is the fixed number which is added on the previous term of arithmetic series, which is called the common difference. Thank you very much.